Today we're going to focus on how to write explicit formulas for arithmetic and geometric sequences in context, meaning from a real-world problem. So let's remember that arithmetic means addition, geometric means constant multiplication, and both formulas are composed of two things. They are composed of an initial value and their pattern, which is either represented by a D or an R. When we're looking at the arithmetic formula, that D stands for common difference. When we're looking at a geometric formula, that R stands for common ratio. So remember, initial value, A sub 1, and then our pattern. Let's go ahead and practice some examples. In a lab experiment, the decay of a radioactive isotope is being observed. At the beginning of the first day of the experiment, the mass of the substance was 900 grams, and the mass was decreasing by 15% per day. Determine the mass of the radioactive sample at the beginning of the 9th day. So first off, what is A sub 1? Well, because it's our first day, that would mean A sub 1. So it looks like A sub 1 is 900. And because I see a percent, it's going to be geometric. So I'm going to go ahead and write my generic form of the equation and plug in what I know. To write our common ratio, convert a percent to a decimal. We do that by moving the decimal place 2 spots to the left. Because this is a decreasing problem, I'm going to subtract. So when I simplify it, I'll see I get 900 times 0.85 and minus 1. Now I'm going to plug in that 9. Type it into my calculator, and see that at the beginning of the 9th day, the mass of the sample, A sub 9, is 245.24, which rounded to the nearest tenth is simply 245.2. Let's try a second example. You rent an apartment that costs $1,200 per month during the first year. First, A sub 1. But the rent is set to go up 8.3% per year. What would be the rent of the apartment during the 8th year of living? So great, I see the word first, so that means I'm dealing with A sub 1, so that's 1,200. I see percents, so that's geometric. So let me go ahead and write the general form of my equation. My initial value was 1,200. I need to convert 8.3% to a decimal. And because it's going up, it's increasing, I'm going to add. So I'm going to go ahead and simplify. I'm going to plug in an 8 into my equation. And I see that at the 8th year, the apartment rent is now $2,096.91, which rounded to the nearest tenth is 2,096.9. Let's take a look at our last example. Nora is a teacher, and on the first day of the quarter, she has 31 papers to grade. She can grade at a rate of 6 papers per hour. How many papers would Nora have remaining to grade after working for 5 hours? So I see the word first, so that means I have my A1. My A1 is 31. There's no percents, so it's going to be arithmetic. And let's go ahead and write the equation. Here's the general form of the equation. My initial value is 31. This is going to be a minus 6 because she starts off with 31 papers to grade. And as she grades, her stack of papers to grade is decreasing by 6. So after 1 hour, she only has 25. And after another hour, now she has 19 to grade. So I'm going to be subtracting 6. We can go ahead and plug a 5 in for n. And see that after 5 hours of grading, she has 7 papers left to grade. Let's summarize what we just learned. If you see a percent, more than likely it's a geometric problem. If it's talking about increasing, make sure to add to 1. And if it's decreasing, make sure to subtract. And as always, you'll need to convert your percents to a decimal. And you can do that by moving the decimal 2 places to the left or by dividing by 100.